So this is homework for question 5. If f of x equals x cubed minus 6x plus 8, show that there are values of c for which f of c equals a, pi, b, negative square root of 2, and c, 7,000. So the best way to begin this problem is to find the values of x1 and x2 for which f of x1 is less than or equal to pi and less than or which pi is less than or equal to f of x2. Or f of x1, pi is between f of x1 and f of x2. The reason why we do this is because this goes along with the intermediate value theorem. This function is always continuous given it is a polynomial, and pi would be in between f1 and fx2. Therefore, f of c would equal to pi would exist and c would exist. So using the intermediate value theorem, we can assume that this will happen. So if we find those values, then pi will be in between there. So f of negative 4 is negative 2 would be our first value that we're trying out. So you plug in negative 4 into the equation because it is in a polynomial, and in a polynomial, the limit as x approaches c is f of c. So as you plug in negative 4, you get f of negative 4 is negative 32. And then you're going to try with a bigger value, such as negative 2. So you plug in negative 2 again into the equation, and because it's a polynomial, once again, the limit of x approaches c is f of c. And then this gives you the value 12. So does a solution exist between negative 4 and negative 2 for f of x equals pi? And the answer is yes, because s of negative 4 is less than pi, which is less than f of negative 2. And as stated before in the intermediate value theorem, f of x equal pi must exist as it is between the values. Now, show that there is a value of c for which f of c equals negative square root of 2. Does a solution exist between negative 4 and negative 2? That means yes, because f of negative 4 is So f of negative 2 is between the values f of negative 4 and f of negative 2. So the negative square root of 2 would be between those two values, and again, the intermediate value theorem will tell us that this value does exist. Finally, show that there is a value of c for which f of c is 7 million. Start with a large x value. In this case, use 185. So f of 185 in this case is 6,330,523. So given it's a polynomial, you just plug in the values. And now you find f of 190, and f of 190 gives you 68,708 and 68. So does a solution exist between 185 and 190 for f of x equals 7 million? And this is inconclusive because 7 million is not between those two values. Therefore, given the intermediate value theorem, we need to find a bigger value so that this value is between those values. So we continue using largest value, and now we're going to find f of 195. And f of 195 is 7,413,713. So does a solution exist between 190 and 195 for x of 7 million? The answer is yes, because s of 190 is less than 7,000, which is less than f of 195. Therefore, 7 million is in between f of 190 and f of 195. And due to the intermediate value theorem, we can assume that yes, this value does exist given this polynomial is a function. And that is the end of the problem.